So welcome back to the channel. Today we're going to be discussing my weekly overview for the contents of week 2. So in today's agenda we'll be going over what gradient descent is, as well as neural networks, and then briefly touching on the Kolmogorov-Arnold's networks. So without further ado, let's get into it. So let's first discuss about what gradient descent is. And gradient descent is an optimization algorithm which is commonly used to train machine learning models and neural networks. And as you can see on this slide here, there are two graphs depicting the gradient descent. So how this works is that the algorithm starts at a random input, as you can see here, and then slowly goes in the direction of the steepest descent. It will sort of make small steps in that direction, and will repeat this process until it gets close to 0, or in this case, the minimum. And for each iteration that the algorithm does, it changes its parameters until it's essentially optimized for accuracy. And this algorithm can be used to train machine learning models to minimize errors as well as between predicted and actual results. Yeah, let's take a look at an example presented to us by Leisha Lee. So they took images from a large-scale image dataset, and they have labels for each of these images that correspond to the data. But now they say, okay, let's randomize it and use a dice randomizer to where the dice has k sides and k represents the total number of possible classes in the dataset. And they use this randomizer to randomize the labels of the data. So this means that the randomized labels, no longer represent the data it's assigned to. So taking this randomized data, they now use it as a training data set to train a neural network model, as you can see here in this graph. So how they styled the training model is that they measured it from the accuracy of the original labels all the way to the accuracy of a completely randomized label. And as you can see here in the graph, as the randomness increases, the accuracy decreases. However, something surprising is that with the training set data, it almost always was accurate, right? Or close to accurate. So this essentially means is that you could eventually fit a neural network that will get a very high accuracy and very close to 100% accuracy. And that the neural network can perfectly fit into completely randomized training data. So which was very interesting. So moving on to the Kolmogorov-Arnold networks, or KONS for short. KONS is a class of neural networks which was inspired actually by the Kolmogorov-Arnold representation theorem. And this theorem stated that, that the idea of any continuous function can basically be broken down into smaller continuous functions. So what this really means is that it suggests that a complex function can be represented using a similar smaller function. And if you look at the screen here, the graphs here, you can see a comparison to other models. For this instance, the MLP, or the multi-layer perceptron model. The KONS offers a more flexible approach to modeling complex functions, as you can see here in comparison. which could honestly lead to more efficient and understandable machine learning models in the future. So wrapping up this overview, I briefly want to talk about Demis Hassabis, who was the Nobel Prize winner for chemistry back in 2024. And in his speech, he discussed that he believes that in the future, we will develop some kind of a good AI model that is able to tackle environmental problems that we are trying to solve. And we basically will be able to solve these problems with in polynomial time, which essentially means he believes that it will be solved efficiently, in the most efficient way possible. And I do want to read off a quote that he stated in this speech, which he said that, quote, any pattern that can be generated or found in nature can be efficiently discovered and modeled by a classical learning algorithm. Now, personally, I do not believe that can always be the case because, you know, when we're dealing with nature, there is always going to be there's always going to be some randomness to some aspects of nature. However, though, I do agree in the sense that if we're talking about more static data that does not change that often, then I believe that AI would be able to help in that regard. So possibly within developing new kinds of medicine, for instance, right? I think we can see AI. We can possibly see AI helping a lot in that regard. But when dealing with abstract data, I don't really believe it could actually be effective. So that's going to wrap up my weekly overview. A little bit quicker this time around. I wanted to focus on consistency and getting my message and information across. So I hope you all enjoyed the video, and I will catch you in the next weekly update.